So this is just a quick video to show you some of the constructions that we've already dealt with before we get into our constructions unit. So the first construction we're looking at is to construct a perpendicular bisector of line segment AB. Now remember what a perpendicular bisector does. Bisects cuts something in half. So when I stretch out my compass, I want to be sure to go more than halfway. You can have different size arcs from the people near you, but you definitely want, as long as you're more than halfway, you could go the full length of AB. But notice how when I move from A to B now, I didn't change the length in between my compass. That's crucial. You could always go back and make sure, but you have to be sure that you keep that same measure in between the arcs. And now that we have two intersections, we can take our straight edge and line this point up so we can construct our perpendicular bisector. Now mine's a little off center. You shouldn't run into that problem because we would line it up. But now I have my perpendicular bisector. Notice perpendicular because right angles have been formed, bisector cuts in half, and I can label where that midpoint takes place because the midpoint is along AB on the perpendicular bisector because it's the point that would cut our segment in half. Okay. Now if I read on to question 2, it says, given the line segment MS, construct a line that would bisect MS. It's the same thing. We don't have to worry about doing it again. You can probably do that one on your own. But as we move forward in 3, notice we're using the compass and a straight edge. Now, one thing I want to make sure, as soon as you see that we're using compass and straight edge, really that word construct. As soon as you see construct, you know you're using your compass and a straight edge. They go hand in hand. There's no measuring, there's no ruler, inches, or anything like that. We need to make arcs and show our work. Now in 3, because we're looking to construct the line of reflection, which triangle RST would map onto triangle R'S', T'. Remember, the primes indicate an image, which is the next picture. The original starts without. It's called the pre-image, but the image is after a transformation has occurred. And a reflection is a type of rigid motion. It's going to preserve length and angle measure. We need something that's going to map those points onto each other. We need some kind of line in between. And a line in between that we've dealt with already is just our perpendicular bisector. So we can pick any of our 3 points, R to R prime, S to S prime, T to T prime to connect. You don't need to connect all 3. I've seen that a lot lately where we're making that mistake. You do not, again, I repeat, you do not need to construct all 3 because if you do, you're going to end up with the line of reflection just in the same spot. You're going to create more work for yourself. It's a common misconception. All we need here is to pick our favorite point and make our perpendicular bisector. Okay? If you chose S or T, totally fine. I just picked R because they were the closest together, but do whichever one you're the most comfortable with. We make that same construction. Remember, our goal is to get 2 intersections. If in any of the last 3 you have not gotten 2 intersections, that means you did not make your arcs wide enough. You didn't go more than halfway. You have to go back and make sure you're more than halfway when you set up this picture. And just to be completely safe for this construction, notice it's a line of reflection. So lines, they carry on forever, infinitely in both directions. So I'm going to give our picture some arrows just to be safe because we know it's a line. In the 4th construction here, we're constructing the center of rotation of triangle ABC onto the image A', B', C'. Now, we're going to do the same kind of concept we did in the last one. We're going to connect A' to A. And if you chose B' or C, those are fine too. But notice I'm giving it a dashed line. I would do this, especially for 4. If you didn't follow that lead in 3, it's okay. But in 4, you're going to see why we might want to dash that connection. And if you don't, there's no points off. That's totally fine. It's your preference. But again, you're going to see why I think this is a little bit more helpful. So I'm going to go to A' and put my clear piece there. And I'm going to stretch out my compass as long as it's more than halfway along the line we've created. I'm just going to go back so you can see this. And as long as we're more than halfway, if you only get one intersection, that means you were a really good judge of intersections and you got the halfway point. But to make a construction, you still need two intersections. So we have from A prime, without changing the length of my compass at all, we go here and construct the arc to get two intersections. Now this, when I connect these lines, that I'm going to use a solid line for. And notice I've done those arcs in red. If you have colored pencils at home and you can bring them in, or you can use them at home as you practice, that's a great technique. I know some of us like to use highlighters or different strategies, but we definitely want that, and that's definitely going to be helpful. Now, if I look on here, I have a line of reflection from A and A prime. That's not my center of rotation. Remember, I need a point. A center of rotation is a singular point. So to find that point, I'm going to do the same process all over again. Only this time, I'm going to connect a different pair of points, like B and B prime. You could have used C and C prime at any time. It does not matter which ones you choose. Again, I'm doing dotted lines, and you're going to see why that's going to be helpful. And I'm going to go in and construct here from B prime to B. Remember, our same technique, we want to be more than halfway along this line segment we've created. We're going to make an arc. We're going to make a second arc, this time with my center at B. Notice I never changed the size of the compass at that point. And I'm going to connect here. I'm going to connect B and B prime's two intersections. Now, we're still not done. We're so close. But notice, now this is why I made dashes. We have so much going on. We have the red arcs from A to A prime, the yellow arcs from B to B prime, the two aligned segments of the perpendicular bisectors drawn in, and the dashed ones we started with. The center of rotation is where the two perpendicular bisectors meet. So that means where these two solid black lines meet. But I'm going to label it P just so we have it for ourselves. It didn't say we had to label it P, but we know where those two perpendicular bisectors meet is where our point is. Notice it's not here where the two lines are just connected. It's not here. This would be the midpoint of A to A prime, just like this would be the midpoint of B to B prime. So it's a matter of following our perpendicular bisectors and finding theirs intersection. If you did it from C to C prime for a third time, you're just doing more work because it's going to actually pass through this point as well. If I go down to the bottom here, we're constructing an equilateral triangle now. And what we should know about an equilateral triangle is that all three sides have to be equal. So we start with one point in our compass. I started with A. At least I started to get close to A, and I'm going to make perfect. Now I'm going to have to bring my compass down here and stretch so that the length of AB is preserved inside here. Now that I have that preserved, that is in my compass, I'm going to make the arc around from B. Without changing the length, I want to go right over clear piece at B this time. When I make this arc, you'll notice that it will connect all the way back to A because it's the same distance in between. And that means this point of intersection, that's the vertex known as C. And to take our straight edge, we're just going to line up points A to C and C to B. And that's an equilateral triangle, my friends. 3 congruent sides. We also should know that an equilateral triangle has 3 congruent angles. All 3 of these angles have to be equal to one another. And that being said, that means they're all 60 degrees. They're 60 degrees because triangles add to 180, and each individual angle being equal, we just divide 180 by 3 and we'll get 60, which leads us right into how we're going to get our answer to 6. We just need to construct an equilateral triangle. Even if one's not given to us, we can make a side. And you can make the side as large, as small as you want, just so that it's comfortable for your compass. But you can make it any size because you can have equilateral triangles that differ in size. We've seen it before. Not all equilateral triangles are congruent. All their angles are congruent, so we know that angle isn't enough to prove that we have congruent shapes. But it is going to help us get that 60-degree angle. So notice I made mine bigger than the last one. So I'm going to stretch it out so that the sides are in here. I make my arc from one endpoint without changing that compass from the other endpoint. I'm going to make that arc. And really, we could construct the equilateral triangle over again. We don't even need to because we only wanted an angle. Oops. So our angle can be from any point. If you draw in the triangle, we just have 3 of them. But in here now, this is our 60-degree angle. Okay. If you connected all 3, then you could use any of the 3 angles as well, but you now have a 60-degree angle intact. When we're constructing a triangle, we want to copy all 3 of the sides. We want to make sure that they are copied in such a way that we have all 3 exactly the same. One technique that you can start with is just by drawing a straight line, because I know that I'm going to need a side. I'm going to rename the new triangle as I go as A prime, B prime, C prime. So I can even start by saying that this corner part right here, that's going to be A prime. So I'm going to start with copying the length of AB in my compass. So I'm going to stretch out. So I start, oops, bear with me 1 second there. I'm going to go over to my compass and have the clear piece at A. I'm going to stretch that out. And again, I got to turn this onto the pen. Stretch out so that we have B prime locked in here. That's our exact copy length. So copying that length, we're just going to bring it over from A prime, that new point, and we're going to make that arc. That's going to be the point known as B prime. So we already have 2 of our points. We still need to get the 3rd point C, however. So to get that 3rd point C, we're going to go copy the other 2 sides. So the first side is AC, starting with our compass at A, like we have, because we have that point already. Show that arc. We want to get full credit. Remember, showing the arcs on the original is the partial credit that we need. Just like as we were adding or subtracting, we would show the steps. So over here, now we go to A prime. Oops. Lost our picture there. And I'm going to make that arc. Somewhere along this arc is where C is, but I don't know exactly where just yet. To figure out exactly where, I'm going to go copy that 3rd side. So this time, clear piece at B, since that's already on a point, and we're going to stretch out so that we have the point B under here. Notice I was a little too large. That's okay. I can just shrink and show that arc. Now we're good. I'm going to go over to B prime, and I'm going to make that intersection. That intersection is going to be the new C prime. And we're going to connect those points. So from A to C prime to B prime, that's our new triangle. Notice it's preserved, it matches the original, and we have all of our points labeled intact.